So let's talk about RAG. That's Retrieval Augmented Generation. It's been a total game changer for making AI smarter, no doubt about it. But we're kind of starting to hit a wall. See, we're at a point where we need to move beyond just finding facts. The next big leap is about truly understanding them. And to do that, our AI needs a brain, not just a bigger and bigger library.
All right, let's get right into it. Have you ever had this happen? You ask an AI a question that seems simple. It just needs to connect a couple of dots, and it just fails completely. It happens all the time, right? Well, today we're going to explore exactly why that happens. We're going to look at this critical blind spot in today's AI and unpack a really cool new approach called GraphRAG that's designed to fix it. And, spoiler alert, it's all about the connections.
Okay, so first up, RAG's relational blind spot. This is the heart of the problem, really. Standard RAG is fantastic at one thing, finding individual facts. But here's the catch. It completely misses the bigger picture. It doesn't see the relationships, the web of connections that actually give those facts their meaning.
And this right here is a perfect example of what we call a multi-hop failure. Just look at the question. Which university did the CEO of the company that makes the F-150 attend? A standard RAG system, on the left, it just gets stuck. It finds a doc about Ford, another about Jim Farley, but it can't connect them. It can't make that hop. But look at the GraphRAG answer. It nails it. Why? Because it doesn't just see the facts, it sees the path between them. It can literally walk from F-150 to Ford, then to Jim Farley, and then to Georgetown University. It's not just finding info, it's following a trail.
And I really want to stress this point. These failures aren't just random isolated bugs, they're systemic. It's a fundamental flaw. I mean, think about it. Breaking a historical timeline, confusing Apple the company with, an actual apple, or just spitting out contradictory information. These might seem like different problems, but they all stem from the exact same root cause.
And that root cause? It's a complete lack of relational context. I love this analogy. It's like standard RRG gives the AI a massive library full of books, but all the pages have been ripped out and shuffled into a giant pile. Sure, all the words are there, all the facts are technically present, but the story, the connections that make it all make sense, that's completely gone.
So, enough about the problem. Let's talk about the solution. How do we fix this? Well, we have to stop handing the AI that pile of shuffled pages. Instead, we need to give it a map of meaning. And that map, that's what we call a knowledge graph. And this is where things get really interesting. Now, a knowledge graph, or KG for short, isn't just some fancy new type of database. It's a totally different way of thinking about information. A fundamental shift. See, instead of stuffing data into rigid rows and columns like a spreadsheet, a KG stores it as a network of interconnected concepts and relationships. And what's so cool about that is, well, that's pretty much how our own brains work, right? We think in connections.
And the building blocks for this are actually super simple. You've got your nodes. Think of these as the nouns in your data. People, places, things. Then you have the edges, which are the verbs. They're the actions or relationships that connect the nodes, like studied or born _in. And finally, you have properties, the adjectives that add all the juicy details. And with just those three simple things, nouns, verbs, and adjectives, you can map out incredibly complex, real-world systems. It's really elegant.
This comparison, I think, really hits the nail on the head. A traditional database, it's basically a glorified spreadsheet, great for storing neat, tidy rows of data, but terrible at showing how any of it is connected. But a knowledge graph, that's more like a mind map. The connections, the relationships, they aren't an afterthought. They are the entire point. This simple shift changes everything. You go from just answering, what data do I have, to being able to understand, what does this data actually mean?
All right, section 3, querying a brain, not a library. So we've built this incredible mind map, our knowledge graph. What's next? Well, now we connect it to a large language model, an LLM. And that combination, that's GraphRAG. This is where you get a system that can genuinely reason over information, not just spit back facts. I absolutely love this quote. The fusion of RAG and knowledge graphs gives LLMs a brain to query, not just a library to search. It just perfectly captures the essence of this whole thing. We're graduating from just doing keyword searches in a giant digital library to actually having a conversation with a structured, connected brain. It's a huge leap. So how does this actually work under the hood?
It's pretty cool. When you ask a question, the system first finds a starting point, a node, in the graph. From there, it literally walks along the connections, following the meaningful relationships, and it pulls out this small, super relevant mini-graph. It's called a subgraph, and that is what it hands over to the LLM. It's like, instead of giving the AI a 1,000-piece puzzle box and saying, good luck, we're handing it a small, pre-assembled corner of the puzzle. That's exactly what it needs to see. And this subgraph approach is what makes the whole system so incredibly powerful. First, the context is structured. The relationships are explicit, like CEO of. It's not just buried in a paragraph. Second, it's super compact. A single path in the graph can summarize information that might be scattered across dozens of documents. Third, and this is a big one, it massively reduces hallucinations because the model can only follow paths that actually exist in the data. And maybe the best part? It's explainable. You can literally trace the answer back and see the exact path of logic the AI used to get there.
Okay, but hang on. What about questions that aren't so black and white? Questions that aren't about direct logical connections. What if you want to ask about something more fuzzy, a concept like safety challenges? Well, that's where things get even smarter. Enter the hybrid model, which gives us the best of both worlds. This whole approach is actually inspired by how our own minds work. Think about it. We use both structured logic, like A causes B, and that more fuzzy semantic recall, where one thing just reminds you of another. It's that System 2 logical brain and the fast, intuitive System 1 brain that Daniel Kahneman talks about. Well, hybrid GraphRAG is designed to mimic exactly that by combining graph traversal with vector search.
So how does it pull this off? With a really clever dual scoring system. On one hand, you have the graph relevance score. This is all about structural proximity. How close are two things in a graph? How many steps does it take to get from one to the other? This is perfect for a question like, who partnered with Tesla? But then you have the vector similarity score. This is all about semantic closeness. How similar are two things in meaning or concept? That's what you need for a question like, what are Tesla's safety challenges? The system uses both.
And here's how it balances those two different scores. It's basically a simple weighted formula, with this little variable called alpha that acts like a tuning dial. If you ask a question that's all about relationships, the system turns the dial towards the graph score. If you ask a more conceptual, semantic question, it turns the dial the other way, towards the vector score. It dynamically figures out which mode of thinking is best for your specific question. It's brilliant.
This all leads to a workflow that is just so much more powerful. It's called scoped semantic search. Check this out. Instead of searching across your entire massive database, you first use the graph's logic to find a small, super relevant neighborhood of nodes. Think all of Ford's EV suppliers. Then, and only then, do you run your fuzzy semantic search inside that tiny, focused space. You're using logic to get rid of all the noise before you even start looking. The results? Way more accurate.
All right, let's zoom out for a second and think about the future, the big picture here. Because what we're talking about isn't just a better way to do Q&A. This is a stepping stone to something much bigger. Creating AI that doesn't just use knowledge, but can actively, and even autonomously, build, maintain, and evolve it over time.
We're literally moving from the idea of a static digital encyclopedia to a living, breathing knowledge ecosystem. I mean, just imagine AI agents that are constantly out there reading the latest news, scanning research papers, and automatically updating the graph with new connections. Imagine them finding contradictions and healing the graph by fixing them. And we're not just talking about text anymore. This graph could connect text to images, to videos, to data tables, all in one single unified network.
And this timeline here shows a really clear path for where this is all heading. Right now, we're using hybrid GraphRAG to get much better answers to our questions. But in just a year or two, we'll see memory-enabled agents that use these graphs for long-term learning. Then comes GNN-enhanced RAG, which is even smarter. And looking out 3 to 5 years, we're talking about collaborative agent networks, multiple AIs working together over a shared graph, a shared brain, to tackle problems we can't even imagine solving today.
And that really is the ultimate vision, isn't it? A future where all of our data and all of our AI share one living, evolving brain. A future where our information is no longer locked away in separate siloed databases, but flows freely into a single, unified cognitive infrastructure. This isn't just an upgrade, it's the foundation for the next generation of discovery, and for what you could call truly intelligent reasoning.